Good morning, everybody. I am Dr. Anandi. I was working in Mumbai as a professor earlier, and now that I have shifted to Singapore. I have written a paper on study of power management in ad hoc networks in International Journal of Science and Research in the year 2017. And I have also given the name of this paper here. So now that I'm going to explain about the abstract of this paper. In wireless communication, listening, receiving, and transmitting are the main source of consumption of energy. This paper presents a survey on the various power-saving techniques used in wireless networking today. The work presented covers topics ranging from the use of energy harvesting, techniques at the physical layer, to partitioning the load of power, hungry computations across multiple devices at the application layer. This work not only covers wireless LAN, wireless PAN, and wireless sensor networks, it also deals with the existing standards for performing power management in each of these networks which are discussed. Now, in the introduction, as wireless networks became an integral component of the modern communication infrastructure, energy efficiency becomes an important challenge due to the limited battery life of mobile terminals. In this paper, techniques for energy efficient architecture is presented in section 2. Devious techniques for power management is discussed in section 3. RF transmitter design is discussed in section 4. And section 5 provides a brief overview of wireless LANs, wireless PANs, and wireless sensor networks, which includes a discussion of how each type of network differs in terms of their requirements for performing the power management. Section 6 talks about the recent advances that have been made in the field of power management, followed by a short description of the products available in the industry, which takes the advantage of this research. Finally, section 7 provides a summary of the entire paper. A plethora of power management schemes have been developed in recent years in order to address this problem. Solution exists at every layer of the traditional network protocol stack, and each of them promises to provide their own level of energy savings. Techniques for decreasing the consumption of energy are necessary to prolong the network lifetime as much as possible, and there are many mechanisms for achieving this task. The standard technique is power saving mechanism. Now let us move on to the next slide, which deals with the main constraints. So power constrained wireless networks. Most wireless LANs are based on the IEEE 802.11 standard, which is known as Wi-Fi. Devices in these networks normally operate at a higher data rate than for devices existing in a wireless PAN. To reduce the power consumed, a power management scheme known as PSM is built into the 802.11 standard. Some of these improvements are for enhanced quality of service, which is 802.11e. For security is 802.11i. For throughput, it is 802.11n, as well as dynamic frequency selection and transmitter power control, which deals with 802.11h. PAN technology was developed to allow personal devices to communicate wirelessly with one another, while devices in a wireless LAN are able to communicate with one another over long distances and at higher data rates. Devices in a PAN communicate within a smaller range and at a lower data rate. The above standards which we discussed are all available. 802.15.1 standard includes a power management scheme to further reduce the power consumed. While it is desirable for wireless LAN and wireless PAN devices to consume a little power as possible, it is imperative for devices in a wireless sensor network. So wireless sensor networks are made up of a large number of tiny, low-cost, low-power, multifunctional devices used for extracting data from the environment. They are capable of taking sensor readings from the environment, processing the data, and communicating it to central location for further processing. So here comes the diagram of power consumption of IEEE based networks. So a variety of networks has been dealt here. Everything has been discussed diagrammatically in detail. So these primary networks communicate smaller. So when you see the diagram, it is more clearer and more understandable. Now, here comes the energy efficiency architecture. The most crucial aspect of sensor network energy optimization is the design of sensor node platform. It is a sensor node hardware that consumes the energy. So if the platform is not energy efficient, no amount of higher level optimization will yield desired results. The workload consists of two distinct phases. The first phase, which is labeled low workload, represents the state of the network in the absence of intruders. Nodes periodically wake up, sample their sensors to detect any intruders, and in their absence, go back to sleep. To provide high energy efficiency in this phase, a sensor node platform should provide an ultra low power sleep mode, since the node spends a majority of its time in sleep state. Provide a rapid wake up capability to minimize the power management overhead. The second phase of the sensor network's workload represents a state when intruder activity is detected. In this state, the nodes perform a significant amount of computation and communication to locate and track the intruder. To optimize energy in this phase, the sensor node should perform its active mode computation and communication in an energy efficient manner. Existing sensor node platforms are unable to simultaneously satisfy all the above requirements. While an ultra low power sleep mode can be achieved through the techniques such as power saving, negligible power management overhead, and high active mode energy efficiency represent conflicting objectives. In the low workload phase, the high-end processor is power gated, and the sensor node uses a low-end processor that provides low overhead wake up. When the sensors detect activity, the network transitions to the high workload phase. The high-end processor is woken up and performs the intensive computation and communication in an energy efficient manner. Once the intruder leaves the network, transitions to the low workload phase again, and the high-end processor is shut down. Such a tiered processing architecture is called a heterogeneous multiprocessor with stacked wake up. Unlike conventional multiprocessor systems where the processors usually operate in parallel, in this case, only one of the two processors is used to execute application functionality at any given time. The challenge then is to decide when and how to switch from one processor to the other at runtime. So this challenge then is to decide how to switch the processor and offer at a runtime based on the observed workload. Next, we are going to see about the dynamic voltage scaling. Dynamic voltage scaling is an effective technique for reducing CPU energy. The goal of DVS is to adopt the power supply and operating frequency to match the workload, so the visible performance loss is negligible. A low update rate implies greater workload averaging, which results in lower energy. Low update rate implies a greater performance hit, since the system will not respond to a sudden increase in workload. Now we are going to see about the RF transceiver design. The decision of the transmission range includes power consumption, reduced coverage, complication of scheduling problem, and the number of sensor nodes. Adjusting the RF output power according to the signal to noise ratio is a way to save power and to ensure good communication quality at the same time. Because the RF output power of this RF transceiver is also programming adjustable, we can adjust the RF output power dynamically by the program. Besides RF output power, the data rate transmission is another factor that will affect the power consumption. We can use lower RF output power to meet the same requirement of transmission range when the data rate is lower. Piezoelectricity is the ability to create an electric current by suppressing certain types of crystal to mechanical stress. The primary advantage that piezoelectric materials have over solar panels is that they are small, do not require access to direct sunlight, and they operate with about 70% mechanical to electrical transduction efficiency. And now we are going to see about the industry developments that has been done with this. The eco water and eco electricity devices are designed to analyze the user's consumption to two major inputs to living spaces and then recommend options for reducing the use of both water and electricity. Eco electricity sensing system detects current and voltage signatures within a building's electrical circuit using a single sensor that can be placed at the meter, breaker box, or in an outlet. These signatures are analyzed using advanced machine learning based algorithms that can determine exactly which devices are being used, when they are being used, and how much electricity they consume. Eco water solution works in a similar way, except that it monitors water instead of electricity. Robotic eel can efficiently scan a source of water for pollution and wirelessly deliver the data it gathers in real time. It is used to find and follow signs of pollution. The robotic eel is outfitted with sensors that make it able to test the water for changes in conductivity and temperature as well as signs of toxins. Luminometers measure the light given off by the bacteria, and that information is transmitted to a central hub for analysis. Waterbeak consists of a series of sensors that measures soil water content, environmental parameters that influence evapotranspiration, and indicators of crop development or psychological status. The data gathered from these sensors is sent across a low-cost, low-power consumption Zigbee wireless sensor networks. These sensors are effectively distributed over the cultivated area, given that different areas of the field have different water requirements. Finally, when we summarize this, in this survey, a variety of different energy conserving techniques for wireless networks have been explored. A brief overview of each type of network has been given, including a description of a subset of wireless PANs known as wireless sensor networks. It is shown that while wireless LANs and traditional wireless PANs may achieve longer lifetimes through the use of the power management techniques presented, low power design in wireless sensor networks is an essential feature. As long as there is the need to continue driving down the amount of energy consumed by a wireless device more and more, research will continue to be done in this field. More and more standards will continue to emerge, and more products will continue to be manufactured. So I think I have explained and given a clear understanding of the paper. Thank you so much.